uses the VLAN, and you can do the sub interfaces. You need one router. And remember, there's about 14 networks there, so I've probably saved you about 400 grand there in your system. So yeah, use .1Q, use your VLANing. Probably give each one of them their own VLAN. Give it its own network. Keep it simple. So try and make it as simple as possible. Build your nice topologies, and then things like insert allowing things. That's your ACL work. So look at what I'd suggest is build a topology. So okay, we need doctors. They'll have a switch, and they'll have a PC hanging off. We need admin. Okay, admin have a switch. Admin have PC hanging off. So on. So build that into a topology, a stone. Okay. Then do your IP addressing, so your VLSM work. Do that. Do it very logically as you build it. Once you've done that, okay, then you can start to look at, okay, how do I implement DHCP on each of these networks? Go look at your DHCP, apply it to what you've already done. Okay. Then just go from that, and then look at these here. And so things like all of the ranges are presented from the internet. Well, that's an access control list, isn't it? So we can implement that. But you can only implement an access control list once you know the addressing. You see why it's nice and logical and staged, and you can do it as you went through. And then, so just keep reading, check what it wants, see how it relates to you, and do a technology. There's always a technology for what you want, okay? So, and then there's this translation bit here. So this is the NAT stuff we've just covered. That'll be your NAT. So apply the natting. Again, you need all your previous information before you can do your natting.
It's all the steps, isn't it?
Yeah, it's all. We're not mean. We have laid it in a nice logical. Do this. Okay. Now look at this. Now bring in this technology. Now bring this in. Okay. And then there's your DHCP. I moved it up a bit personally, but I didn't write this. Right. But there's DHCP again. You can only apply that once you know the networking. And then this is what we always use. This use the marking grid. Use this, okay, because that's what we use to mark it. So again, we're not hiding anything from you. So if we've, as you can see, we're saying, well, we want to see your VLSM, and we've even given you the table for it. Yeah. Okay. Provide a router config file. Okay. Give me the router config. So put it in Packet Tracer, and then just output the router file for me. Yeah. So show me Packet Tracer. Show me it working. Okay. Show me DHCP, show me PAT, port address translation. So what I would do there is assign your outside port the address, and then shove everything through using PAT, which we've shown you how to do. Okay. You've got your access controller, show me everything, show me the ability to get this, because when we go back to the marking scheme is literally page 2. So if I can see your IP addresses in VLSM, tick, 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 5 marks. Winner. Okay. Router configuration. Can I see DHCP? Tick. Can I see ACLs? Tick, tick. Yes, these ACLs do what they want. Can I see this? And this is how we're marking it. Switch configuration. Can I see switch port security? Can I see VLANs configured correctly? Can I see all that sort of chat? Tick, 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 tick. Boom. Discussion of WAN technology. Okay. Discuss why you've done stuff. Discussion of your VLANs. Okay, why have you used your VLANs? What are they doing? What is this adding to the network? What's it preventing? That sort of stuff. Boom, 10 marks. Tick. Format of the work. Okay, so I want it in a Word document. I want it to look like a professional report. If you're really stuck for ideas, front title page, contents, section 1, section 2. Don't have to be complicated. I don't want it to be the prettiest thing in the world, as long as it's got a professional layout. Cool. And again, Harvard referencing should be using that for everything at university. So again, it's all standard. It's all nice and simple. That's what we try to do with this. Presentation of work. So obviously, you've got to do a presentation on this, but you can't do that until you've got the thing prepared. And the presentations are after the hand in, so don't worry too much about that yet. Okay. And then your individual work. Again, this is what we're looking at. General discussion of forensic investigation devices and their software and their use importance. So try to relate it to you guys. Bring in your forensics knowledge. Okay. What could we do forensically on a router? What can we learn from a router? What can we learn from switches? What can we learn from PCs? What can we learn from the addressing? So what could, if you compromised a PC in admin, what could it actually get to? If we compromised X, what could damage could it do? That sort of thing. And the use and importance. So
Would you use that to justify why you use certain?
yeah, things like VLANs. We've prevented admin to talking to doctors, for example. So if we get a compromised admin PC, for example, on this case study, that compromised admin PC would never be able to talk to the doctors. Or things like, I think there's cameras involved. Yeah, there's some IP cameras monitoring the building, but we've denied them access to the internet.
Yeah.
So why have we done that? Well, actually, if I was a hacker and I wanted to see what's going on in this place, I'd log in remotely to your IP cameras. Ooh, so he walks every Friday, he walks out at 3 o'clock. Okay, I'll kidnap him later. Okay, still sounds simple, but you've just prevented that by saying, actually, cameras now, they don't need to see the internet. And then I've got to go on site if I'm going to try and break into your camera network. Simple, but effective. Okay, and that's what you need to be considering. Little things like that, but as you see, I'm making this up on the spot, sort of thing. So there's plenty to talk about. Discussion of your recommendation of forensic investigations. So I don't know if you know about firewalls, your antivirus, that sort of jazz. Your IDS, if you want to look into that technology. IPS, again, similar-ish technology with a different approach.
To be installed on the workstations.
You can install it on the workstations. You could be looking at specific pieces of hardware. For instance, there's firewall security appliances in the racks there. That little jazzy thing with the screen and the lights in the green rack. That's a firepower source fire firewall. Very nice piece of kit. About £9 grand. That tiny little box. Okay, but that's another technology. You can get hardware firewalls. Software firewalls on the PCs. You've got things like IDS, so intrusion detection systems, so which again could be a piece of software, could be a physical box that's taking in traffic, looking at it, inspecting it, passing it on. That's detection, so it's just looking at the traffic, going, is there a problem, is there not, right, and go with it. You've got intrusion prevention devices, so they look at your packet, analyse it, go, that looks a bit dodgy, bin it, or that's cool, that's what I expect, legitimate traffic, on it goes. So you've got different systems like that you could look to implement. And anything else you can come up with, I mean, Is there a budget to this? No, there's no budget to it. But again, we're not actually asking you to go and build it tomorrow, so it doesn't need to be perfect, but you've got to be conscious, okay, we're looking to create, so if you remember, you're part of a bigger module with our network engineers. So for them, theirs are quite slightly different. They're looking at more the network technology side, whereas we've changed this bit to look at the forensic side for you guys. But again, obviously, if you find the most fancy system in the world, but you're working for schools and it's 400 grand, it's not going to happen, is it? Okay. Again, so it goes back to the same thing with routers. Yeah, sure, you could implement a router for every single VLAN, but it'd cost about 400 grand to do, and you know, let's save a bit of budget, let's use VLANing 802.1q trunking, and oh good, I've just saved you 400 grand by implementing a protocol. Best budget saving ever. Okay, that's the sort of thing. So obviously this bit's individual, so you'll write that yourself. Are you a group?
Yeah.
Winning, so you're with your friends at least, that always helps. And then this bit is group work. The only thing I will say, work together on it. So if he does something, you two check it, make sure it works. Again, same thing, use each other. Actually, don't just say, oh, you did this bit, you did this bit, you did this bit. If he makes a mistake, you two have shot yourself in the foot, effectively, by not checking. So then it takes, what, an hour to go and check? But you can bin out stupid little mistakes, or oh, you've got that wrong, or that doesn't make any sense. You can save yourself a load of work.
On the individual reports?
On the individual reports, no, they've got to be your own. Okay? But this bit, you can. That's where you'll save yourself some marks. I always say, measure twice, cut once. Old engineering adage works also here. Make sure you write something down and you check it before you say, right, that's what we're going with. Especially, like I have done for that guy there, who was in earlier, asking me about the VLSM stuff. Again, if that's wrong, it makes going to make that bit difficult. It's going to make the next bits difficult. Not impossible, but difficult because you've made a mistake earlier. So lots of checking is all I can suggest. Proofread it, and make sure your maths is right. So again, if one of you's good, make him do it, obviously, if he's good at it. And then don't just say, because you think he's good at it, don't take it. Take a look at it, and then do it yourself, and go, actually, yeah, okay, you've got that bit right. That's right. We've got different answers. Who's wrong here? Okay, you see what I mean?
Yeah.
That's it. That's the secret to the case. We have tried to make it logical. I know it's a bit